Okay, so recording has started. We'll start with the lecture, and as I told you, please from now on, I don't want you to miss any class at all. All right. So today we'll talk about abstract class. Before this, just let's go and check the previous lecture, the main topics of the previous lecture, which was about the inheritance in classes. And I think we explained this more than one times, in 2 or 3 times we repeated this. We say the principle of the inheritance is to create a superclass that all the subclasses can inherit features from it. And this was a simple example. Of course, I prepared a very comprehensive example. We will go through it after we finish this lecture. I can show it to you now. Yeah, it includes all the principles of the classes. Okay, case study, and I implemented it. It includes everything starting from attributes, then the method. Then after that, the constructor, how to build the constructor. If you understand this example, then everything will be easy for you. Encapsulation, abstraction, inheritance, and polymorphism. Okay, so we implemented everything in one example so that you will be familiar of everything, or we'll put everything together. All right. So again, we talked about the inheritance here, and we showed that different examples of inheritance. Then we talked about the mode of inheritance. Okay. The constructor here, also the constructor, how to write the constructor while inheriting from another class. Also the mode, inheritance modes, and we say we have 3 different modes, and we talked about the public mode, the protected mode, the private mode. Then I gave you this example to show you how the modifiers or the access modifiers will be changed according to the mode. Then inheritance type, which is very important. We took an example here. We discussed the single inheritance, in which only the derived class can inherit from one class. That means single. This is an example of the single inheritance. Multiple inheritance, if a derived class takes or inherits features and attributes from more than one class, and we took an example about it. Multi-level inheritance, this also we discussed. We say class 2 inherits features and attributes from class 1, and the derived is inherits from class 2. That means it inherits from 2 levels. This is the first level and this is the second level. All right, that's why we call it. Of course, we can have 3 levels and 4 levels based on the application. All right, but here it means the derived class inherits feature from multi-level classes. All right. Also, hierarchical inheritance. When a class, hierarchical means just like a pyramid. Class B and class C inherits from A, and class F inherits from B, class D inherits from C, and so on. All right, and also we cover this with an example. And hybrid inheritance, it means there is no regular way to describe it. For example, here, class 5 inherits from class 2. It's a single inheritance, while class let's say 6 inherits from class 3, which inherits from class 1. It's multi-level. Here is double inheritance. It means multiple inheritance. Okay, so this is all about the inheritance. The rest of the principles of of classes will be covered now. We'll talk about abstract class and polymorphism. All right, abstract class. Why we have abstract class and why we need it. Abstract is displaying only essential information and hiding the details. All right. To think about it, in other words, class and functions from outside the class can access only the essential information and all other details are hidden. For example, consider the car. Let's talk about the car. When the driver can start the car or starts the car, all right, and drive it, but he or she does not know what's happening in the engine or other parts of the car because they are hidden from him or her. That means even you or myself, when I start the car, okay, I don't care about the fuel and the gearbox and the engine and everything else. I have only a key, okay, and I have a car. All right, just put the key and turn it on, or even push the button and start your car. We don't know what's going on inside the car. This is the abstraction. It means I don't need, as a driver, to know how things are happening inside the engine. I only need to know that I need to put the key in the ignition or to push the start button and shift the gear and press the accelerator. This is all what I want to know. And of course, to use the steering wheel to drive the car, etc. But I don't know what's going on here. This is another example. In your cell phone. Now everybody is using cell phone now to text message and call and do a lot of things. All what you want to know is how to use, right? How to use it. You don't care about the software and the hardware inside the phone. So in everything, the user do not or the users do not need to go deeply in details. In some case, of course, some people are doing this, but this is not the general case. So this is the abstraction. It means only to display the necessary information that interests or that are interesting to the user. Okay, the same thing in the classes. I'll define, I have class, and I have, of course, abstract class, okay, in which all the classes can access this class without paying any attention to the contents of the function. For example, if I have function here, x, y, z, all right, I don't need to worry about how it was written or how it was developed, or I just want to access it from outside the class. So this is abstract. And by the way, the word abstract, even in research, when you read the abstract, you will find the most important information, the essential information, and the details will be in the text or the manuscript of the research. So this is the basic idea of having abstract class. Now, example, consider this shape, okay, as a class. All right, I have shape class, public. I have now you will see that I have two new things. These are the new things. Okay, we will call it pure virtual after a while. Okay, so in general, in the past I used to have get area, right, and set W as width, set height as set H as double H, all right, and protected W and H, or even private is all right here. Private is okay, okay, because I can access them. Now, the double area, get area, in the past, we used to write some code here, okay? But now I added virtual and equal to 0. That means I'm I made it as something we call pure virtual. What does that mean? Pure virtual means that all the classes, okay, all the derived classes should have a function called getArea. Okay, if I don't put virtual and equal to 0, that means it's optional, either to have it or not to have it in the derived class. But when I put virtual and equal to 0, that means all the derived classes should have a function getArea and define it. So the function virtual double getArea is defined as pure virtual and equals to 0 to make it mandatory for all derived classes to define it inside the class. All right, so here, if you can see, I have class rectangle inherit from public shape. If I don't define this double getArea inside the class, I will get error. All right, so return W by multiplied by H, class triangle, public shape inherits from the shape. Also, I have getArea, which returns W times H divided by 2. Class square also inherits from public shape. Here also I have double getArea return W times H. So if I declare or define a class, whatever the name is, which inherits from shape, and this class doesn't have getArea, then I will get error. All right. Why? Because I made it mandatory by equating it to 0. All right. So let's see here. Rectangle and triangle and square are derived class from the shape class. They inherit all the members of the class, but each one should include a definition to the virtual function. All right, so we're going to the polymorphism because here it's very important to implement it. I want you now, all of you, to implement this class with me. All right, so what I'll do now, I'll define the class shape. Without virtual, now I'll define it without virtual, just to show you the difference. Here I have double. Let's define first private double H and double W. So now nothing new, right? Public area, or let's first void at H of double X, in which all what I'll do here is to put H equal to X. All right, and also I have void set W of double X, no problems if they have the same name. So W equals to X. That's some column. Done. Now I have to define double getArea of course I don't need to use now the or I don't need to pass any parameters because it will use H and W, right? So here return H times W. It's not always the same, by the way, but here let's consider that I have this. Okay, then I have semicolon now. Now this is the shape. Okay, and usually I don't prefer to use this return HW, but we'll use it now. Okay, now I have sorry, I have this column. All right, so now in the main function I can define shape. Okay. And I can use s.set. Say I'll pass 5 and s.set w. Let's say I'll pass 7. Okay. And also here I will get the area, right? So double equals s.get area of that's it, and print the area is cout. The area is okay, and I will write A and end line. All right, let's execute this and see the result. Okay, so successfully start debugging. Okay. Okay, so if you can see, the area is 35. So now we didn't do anything. We just defined the shape, and we a class called shape, and we defined the variables h and w. And now let's define another class, another object, which is which inherits everything from public shape. Okay. Now, if I don't write anything here, then it's almost everything is applicable here. H, W. Then let's try, instead of using shape, I'll write rectangle. Okay. Nothing will be changed, as I know. Okay, so run. Same thing, right? Although I'm using another class, which is rectangle, because actually what I've done here, when the rectangle inherits everything from shape, but this is not applicable when I have, for example, a triangle. Okay, class triangle. Okay. Okay. I can use it as is, all right? Another class, but here what will be the problem? That the area of triangle is different, right? So let's use now. I will not do anything till now. I will just go and change this to triangle. And execute it. I'll get the same result. Nothing will happen because till now we are inheriting everything from the shape. Okay. 35. I didn't change anything till now, but 35 is not correct. Why? Because the area of triangle is not 35, right? And not h times w. Actually, if you go to Google, if you don't remember, and write, it's divided by 2. but it's okay. Area of triangle. All right. H times B divided by 2. Okay. Here I have 5 and 7. All right. It's supposed to be 17.5, but what I got, why? Because I'll go back to our program, because here the area, I used the same area defined in the shape, correct? Which is W times H. How to overcome this? I can override the area there by defining a new or the same function, okay, but with different calculation or different instructions. So here I can define that I can take the same area here. Okay, I'll take it and write it in triangle. All right. So double get area return H W here. Where have okay. One second here, I have to use it. Okay. Here I need to define divide by 2. Okay. Get area. That means return. We have, this will be a bit confusing to you. I will define here also double, or we need to define the constructor here. I'll define first here double x, okay, and double y, okay, and return here. I need to make them public. Return x times y divided by 2. All right, but till now I didn't achieve the goal of having the classes. Although I defined, by the way, here, let me just triangle dot s. Sorry, so s dot x equal 5 and s dot y equal 7. All right, then double area equal s dot get area. Then I think we'll get it correct. We'll get the right answer, but we almost we are not achieving the idea of or satisfying the idea of inheritance. Yeah, we got a 17.5. Although we got the correct answer, but we almost didn't satisfy the main idea of inheritance, because here I defined x and y. Okay, notice that although here I have 2 gate areas, but what will happen here? Let me just first print, sorry, take screenshot, and I'll explain to you there. All right, very well. So here, if you can see, I have 2 gate area. This is one, and this is the second one. And in the first time when I used rectangle, all right, I executed this directly. Why? Because I don't have here gate area. But in the triangle case, what has happened? First of all, it found that 2 gate areas are available. It will go first to the derive the class and found that gate area is there, so execute this and that's it. Okay. No need to go and execute the other gate area. While in the first case, in the case of rectangle, yeah, okay, it went to the rectangle, searched for gate area, didn't find it, then decided to go to the basic class and execute the get area. So in this case, if I have a function, okay, A, B, C, for example, in the superclass, and I have in the derived class, this is the first class, and this is the second derived class. Let me just expand this. Okay, this is the second. If the function is defined here, okay, the same function, then it will execute this one. If it's not defined here, like in this case, it will jump to the superclass and execute that function. Okay, the same thing, of course, if I have multiple inheritance. So if I have another one here, which includes ABC, then when I come here, I find ABC, no need to proceed. I'll stop here. I will not go to the other one, then to the super class. All right. So in this case, the first one, the computer faces or finds will be executed, and the others will not be executed. Okay. So this is the main idea of having more than one function with the same name. This is called overloading, and this is what we'll talk about it. Now, what should we do to make, see, for example, here rectangle, we don't have definition for, but it was executed, right? There was no errors. We don't have the function to calculate the area. So in order to make it mandatory, please focus with me. This is very, very important step. I will write here virtual, all right? Remove the definition from here to 0. Okay. Now, if I execute this, I'll get error. All right, let's run it. One second, I think virtual get area. All right, terminal. I don't know, I should get error just because maybe I didn't. Okay, rectangle as of x. Set W of 6. S dot set H. Okay, let's run it. Still, it's working with the old one. Okay, so yes, with errors now. Let's see the errors that we have. Okay, see, the area is A. Here is the error. A was not declared in the scope in 27. So that means here A. No, this is not the error. This is the error. All right. Now let's also compile it. Errors also. Let's see the errors. Yeah. Now the correct error that we got. Note, virtual double shape get area, virtual double area is not defined, right? So here I have a problem because the following virtual function are pure within rectangle, class rectangle, public, etc. So many errors I got. Cannot declare variable s. Let's go through the errors one by one. The first error is error. Cannot declare the variable s abstract type rectangle. Why? Here we have error. It cannot be declared. Why? Because s is a rectangle, and when I go to the rectangle, okay, I'll find that rectangle inherits from shape. When I go to shape, I'll find I have a pure virtual function in that class. That means I have to declare this in every class that inherits from this class. So here, to overcome this problem, let's read the rest of the errors and we'll fix this. All right. So because the following virtual function, which is are pure within rectangle, all right, and that means I have to declare or define get area equals 0 in the rectangle. All right. So I'll remove this something extra. Okay, let's go to rectangle. Okay, in rectangle, I will define double area of, okay, which return h times w. All right. So this is the first one. Let's build it with errors. Unclear private here. Yes, here private protected. I'll tell you why they are protected. They should be protected with errors also. It should be public. Because I want to access it, so it should be public. Why have changed this protected? Because in derived class, the derived class need to access h and w. Okay. In private, there was an error, so I changed them to protected. And we say in protected, the variables can be accessed by the derived classes. So here, I have declared public double get area. Now I will not get error, but also since we are running this and working on this, let's define the double area and the get area in the rectangle class also. Triangle. All right. Now see, I have the same function, but with two different definitions. So if I have, for example, I'll define rectangle R, okay, and R, that's it. R dot set h is equal to 5 dot set w is equal to 7. I'll use the same numbers, and also now I can get let me define the triangle also. Triangle T dot set w, set h of 5, and T dot set w of 7. All right. So till now, everything is correct, and we don't have any issue. I don't know why you have errors here. Okay, so I declared R, which inherits W and H, set W and set H from what? From shape. And I have triangle T, which inherits also set H and set W from the same shape. Okay, so let's run. Okay, so now nothing happened, but I'll explain to you also again. Let me just take concentrate with me, please. Now, of course, I couldn't take the entire thing. So here, just to remind you, here we have class shape. Okay. And in this class shape, I have double H, double W. I have a public. Here they are protected. I changed them to protected. Why? Because I want to access them from derived classes. And we say always protected can be accessed only by what? By derived classes and friend functions, and we will explain the friend function and classes later. All right, so here I have public void set w, void set set h, void set w, and I have virtual, pure virtual. This is the abstract. This is the representation of the abstract abstract idea. Okay, so here I have virtual double gate area equals 0. Why equals 0? Because I want to make it mandatory. Okay, that every derived class should have gate area, and if you don't have, we'll get error as we saw. Here we have declared rectangle, public shape. In this case, public double gate area return h times w, and in triangle, public shape derived from public shape gate area h times. See, although the same name, but it will when I declare this and let's go to the code. When I declared this here, what I got that here, for example, in rectangle, I will call cout the area of the rectangle is okay. What is r dot get area? Cout the area. Let me just copy this. Of triangle is T get area. See, I'm using the same function, right? The same name, but from different classes. So in this case, let's execute this. All right, run. Sorry. Okay, you can see, although I've used the same function, but the first one returned 35, the second one returned 17.5, because different functions. Now suppose that also I want to declare another shape or another shape like square. Squares V is very easy because it needs only one dimension, but also you can define the gate area and to use it directly. So what I'll do now, I'll share this with you, this code with you. Okay. I want you to implement this, and let me just change it to this side. It's editable. You can copy and paste it, of course, but at least I want you to implement it and to make sure that it works properly. Although it's very small in size, the text, you can copy it. Just copy it and study it carefully. All right. Okay, so this is all for today. If you have any questions, please feel free to ask. I'll share this document with you now. Okay. If you have any questions, please feel free to ask. Otherwise, thank you very much. You can leave now.